So we would go and add different features like variable boost levels that would be adjustable on the fly. And those sort of things were quite trivial to add, but they were very common in the aftermarket world. And being able to do that in the OEM computer and be able to configure that using hardware already in the car. So your cruise control buttons, for example, we use those to adjust the tune or boost level.
Welcome to the HPA Tuned In podcast. I'm Andre, your host, and in this episode, we're joined by Roland from PCMTec in Australia. PCMTec's a tuning solution primarily for the Australian domestic market, Ford Falcon, BA, BF, and FG, as well as the Ford territory. More recently, though, they have also branched out into the US domestic market, Ford, F-150, and Mustang. We talked to Roland about his background and how he saw, what he saw as a gap in the market with the current existing reflash technology and how he came to develop PCMTec. We also talk about what reflashing is, how this actually works, how PCMTec are able to add additional functionality in, such as map switching on the fly, just to name a few of their custom software features, into what is an existing factory ECU. We also talk about the increasingly grey line between where someone should be looking to reflash and where someone should be looking to switch to an aftermarket standalone ECU. Before we get into our chat with Roland, for those who are fresh to the Tuned In podcast, High Performance Academy is an online training school. We specialise in teaching people how to tune engines, how to build engines, how to construct wiring harnesses. We also cover topics such as race driver education, race car setup, 3D modelling, and CAD. You can find all of our courses at hpacademy.com/courses. All of our courses are delivered via high-definition video-based modules that you can watch from anywhere in the world, provided you have an internet connection. This means you can learn from the comfort of your own place and you can learn at your own pace. All of our courses also come with a 60-day, no questions asked money-back guarantee. So if you purchase and for any reason at all decide it wasn't quite what you expected, let us know. You'll get a full refund of the purchase price. As a podcast listener, you can also use the coupon code podcast75. That will get you $75 off the purchase of your very first HPA course. We'll put a link to the courses and that coupon code in the show notes. Lastly, if you like free stuff, then head to hpacademy.com/giveaway. This will show us the current giveaway that we're running, and we partner with some of the biggest brands in the aftermarket performance industry. We might be giving away wiring tools, we might be giving away an aftermarket ECU or an aftermarket dash, maybe a power distribution module or car setup equipment. These are high quality giveaways that I know you're going to love. It's really easy to get your name into the draw. There's no catch, no purchase is necessary, so don't miss out. All right, enough with our introduction. Let's get into our interview now. All right, welcome to the podcast, Roland. Thanks for joining us, and as we always do, let's get started by finding out a little bit about your background and specifically how you got involved in the automotive scene.
Yeah, so like most car enthusiasts, started off in our teenage years. I was an avid Skyline rotary fan. We had friends mostly in the rotary scene, but I was always more of a piston fan. I had probably 6 Skylines over the years, and I broke probably a gearbox in every single one of them at least once.
So standard modified car scene.
Yeah, yep. And also broke, do it ourselves, do it poorly, learn along the way. We got pretty good at changing RB20 gearboxes in Skylines.
I think there's something to be said for that inevitable learning curve when you've got more passion than cash and just figuring it all out as you go.
Exactly. And it helps when you've got a friend who's a mechanic and you don't have a hoist, but you've got tools and things like that. But that started probably when I was 17, 18, back when turbo cars were quite cheap, easily accessible, and just good fun.
And we should probably clarify for our listeners, you're located in Australia just for the access to the type of cars that you've got, which will become more prevalent as we go through this interview as well.
Yeah, very similar to New Zealand. So we had very cheap access to Japanese cars back in the day, which has since dried up and they're very, very expensive, as everyone knows. But they were quickly replaced by the more domestic market the Ford Falcon and Commodores, etc., which became the staple. But that happened quite some time later. But yeah, we basically did lots of home modifications, tinkering, got our cars tuned, or thought we didn't really know what we were doing. But we're all reasonably smart people with a background in electronics as hobbyists, as like kids. We built alarm systems for our cars and all sorts of things like that. So yeah, that was the general background.
Let's dive into the sort of education background. So electronics, that's sort of your forte, electronics and computer programming. Is there anything sort of around formal qualification in mechanical education?
So I never did any formal mechanical, although I don't know if 20 gearbox swaps counts, but
it's worth something.
It's definitely worth something. So my formal qualifications, so I obviously finished high school and then went to uni, changed degree a few times, started off with electronic engineering, then went into computer systems engineering, which is very similar. It's basically an electronic engineering degree, but with a heavy focus on programming. I did that over about a 6 to 7 year period. It's a 4-year degree, but I got employed about halfway through the degree. So I started to work almost full time about halfway through and dragged the degree out as long as I could, as working was much more interesting. We got paid.
Definitely. But got through the degree in the end.
Exactly. Yeah. So that finished in 2010, I think, roughly.
Okay. At this point, were you sort of angling towards a career in the automotive industry with that qualification behind you, or at this point, absolutely not in the car side of things, just passion?
Not at all. I was just looking for a job, to be honest. I was very heavily into programming on the side, but most of the well-paying jobs were in defense, oil and gas. They weren't so programming focused, but they definitely had an element of programming. There's a lot more electronics, electrical systems, control systems. And I ended up in the oil and gas industry. It was a great Kickstarter to your career working in that sort of field. Although it's a bit different to a car engine. You'd have these gas turbines and these massive 24-cylinder, a couple 100-litre diesel. They ran on all sorts of different fuels and mixers and things like that. Now primarily pumping stations, just to pump gas from oil and gas wells from Central Australia, very, very long distances.
And what's your specific involvement in that field?
So basically, as a control systems engineer, it's sort of imagine you've got a funnel, and at the top of it, you've got your mechanical engineers designing all the pipe work, all the everything that's going to connect and be laid out and where it's all going to fit. Then you've got the electrical engineers, how it's all going to wire up, all the valves, all the systems, things like that. Then you would have the PLC programmers, which is a programmable logic controller, which was essentially my job and that was to run the electronics that would run all the valve safety systems, flow loops, pressure control systems. And all of these sort of fields would come down into this funnel and you'd be at the bottom, you'd be out on site and nothing would ever really be built to spec and you wouldn't go home till it worked. So you could quickly learn these other fields and get literal hands-on with all of the different systems. So you would learn about high pressure control systems. So we're talking 6,000 to 8,000 kPa. So some serious high pressure liquids as well, gas separation.
I'm guessing in this industry as well, there's a fairly high level of consequence if you get it wrong. I mean, worst case scenario with an automotive engine, I mean, no one wants it, but maybe we'll melt a piston, maybe a rod exits the side of the block and you pull over to the side of the road and call a tow truck. Lives can be lost in the oil and gas industry if you get it wrong.
That's it. The consequences are catastrophic and you have seen them. They do a layered approach of safety. So they call it SIL, different ratings. I'm not sure what the SIL stands for, but basically it's how many lives can be lost really if something goes wrong. And I'll do a layered system. So they might have a very simple software, say let's overpressure, just like in a car, like too much boost. Let's cut the engine down. And that's purely done through software. And then they would layer it down again and have a mechanical sort of override, like a pop-off valve that you might have seen on the older turbo cars, which is like your pressure relief valve. And then if that failed again, they would have like fusible link systems, which are like wax plugs in pipes. So if you had a fire, I mean, it's as simple as that, like fire melts wax and lets air out of a system. And you have a fail-safe valve that closes. And all of these different layers would sort of protect each other. So you'd have to have quite literally hundreds of people fail to do their job and test and not test everything for something to go wrong. It's similar to a car though as well. So in a car, you've got your throttle body. You're not going to run that just from an analog output with no control system behind it. You're going to be checking position feedback, go, well, I've asked for half throttle. Do I really have half throttle? Is it stuck open? Is it not opening at all?
So you've got that safety checking strategy that the ECU is always doing. Is what I've asked for what I'm actually getting? If not, then we've got the option to bring in some safety strategies, maybe a low RPM limit or something of that nature.
Exactly. And some great examples are like an intake manifold leak after the throttle body. The throttle body's shut, but you're making torque. You're seeing the engine revs climb. Obviously, they'll call that a plausibility checker in the OEM world. And it's not plausible for that to occur, shut the engine down. And there's a lot of crossover I found with that, with how the car's safety system worked, the control systems worked, and also the oil and gas industry. So it was quite a logical step moving into the automotive industry.
Sure. Now, just coming back one step, the PLC programmable logic controllers. I hear about these a lot in the industry. I don't deal with them, but is it safe to assume there is a fair bit of crossover between how these work and some of the automotive systems?
Yeah, so back in like the 70s, when computers were expensive and difficult to set up and very limited, everything was relay-based, so relay-based logic. So like in your car, you'd have fuel pump relays. Maybe if you looked at a 1980s car, you would have a handful of relays at most. And so they'd run these systems purely off relays with timer relays. They'd all be piggybacked, and you'd walk into rooms that were maybe a couple of meters by a couple of meters, like a cube, and you'd walk inside them and you'd literally be surrounded by relays everywhere, all like feeding into each other, piggybacking. And you would literally get rats in there. So they would call it a software bug now, but back then you'd have literal bugs eating wires. And that's sort of where the terminology came about. But that quickly became obsolete and unmaintainable. And they moved this relay logic into a PLC, which is like a programmable logic controller. So you'd have these ladders, you could imagine like a row of relays, and you could design this in software instead of through literal hardware.
So it's sort of gone the same route as the aftermarket electronics in the automotive industry with solid state electronics, power distribution modules essentially.
Exactly. Yeah. And you're going to have some relays at the end with your high currents and things like that, but all the simple logic like on-off switches and things like that, they don't need to be a relay. They can all be done in software. So that was basically the PLC side of the world. I conquered probably 15 different products. They're all very different, but doing the same thing. Some are very ancient. Some are from the 1980s. I remember one, I had to find the software on a website called ccompilermuseum.com. It was that ancient. There was a museum website to sort of archive old software.
Right, okay.
And that was the only place we could find it to get this old system working. So,
sure.
Yeah, it was an interesting world.
Would I be off the mark in assuming here that with what you're doing in the oil and gas industry, you're also delving into control strategies like a PID control algorithm for some of the functionality, which again crosses over to the automotive industry?
Massively. So like PID, proportional integral derivative controllers, which I imagine everyone's heard the term, but not everyone necessarily would know what it is or how it works, but they were prevalent everywhere. So let's say you've got a pipeline and you've got a pressure set point you want to maintain it at, or a temperature set point perhaps. So a good example, a dumbed down example, is you get in the shower in the morning, you turn the tap on, it's too hot. That's your error saying it's too hot. So you turn the tap back, it's a bit cold. You turn it again and you keep fine tuning it less and less and less. Each time the error gets smaller, that's your proportional controller effectively. So in the oil and gas world, we would have flow control, pressure control, temperature, but you would also have lots of different loops all over the place that all feed into each other and some would override each other. And they became very, very complex depending on what was online and what was offline at the time. And whereas in a car, you might have a few loops like that to interact, but they're generally simpler. You might just find a single loop that runs. And it's called a loop because it's literally a feedback loop of error and correcting that error. basically with a valve or something like that.
I feel we've gone a little bit down a rabbit hole here and off our key topic, which we will absolutely get back to, but I think this is worthy of diving into a little bit more detail. In my experience dealing with professional and amateur tuners out there, the PID tuning is probably one of the areas that there is a lack of understanding, and tuners really, really struggle with it. And the problem with this is if you don't understand the relationship between the proportional, integral, and derivative gains and how to approach tuning one of these control strategies, you can get yourself so far out of the ballpark that you can't see your way back. So I think it's really important for those who are wondering what on earth we're actually talking about. So these PID control algorithms are used for a number of our functions in the automotive scene: idle control, cam control, drive-by-wire, throttle control, boost control, just to name a few. And understanding the principles behind that PID tuning are fundamental in getting all of those elements that I just talked about to work really, really nicely and do a good job. Otherwise, classic example, the one I see all the time is boost control, where we're targeting, let's say, 200 kPa, and the car comes up on boost and just does this gentle, or maybe not so gentle, oscillation up and down around the set point. And for me, it's just a sign that the job hasn't been done properly, and either laziness or a lack of understanding, probably the latter, I imagine.
And yet, prior to this, we would have no PID control. So you'd have your little ball and valve that you'd twist to increase your boost level back in the day. And or you might just put an air leak in there or increase the hose length or something like that. So that would be like your base duty cycle, I guess, or your base map. So your open loop is what everyone tends to refer to it, or feed forward in the OEM world. And that's basically let's assume everything's perfect and static. We're in this environment, it's unchanging. And you set up for this pressure, we need this position, job done. And then suddenly the temperature changes, load changes, etc. And that's where the PID comes in and takes that base set point and then adds on top of that. And then that covers your different scenarios as well. So you might be going up a hill with a trailer, you might be coming down a hill, you might be up in the mountains where the air density is different. There's all these changing conditions. And whilst the PID will bring you back into the right area, if your base set point is so far off, you're going to have all these weird issues, like drivability issues and things like that.
I think what you've just touched on there is, again, worthy of a bit more detail. The whole process of tuning PID really comes back to actually starting, at least in my opinion, the way we teach it is start an open loop. Open loop, base duty, you called it feed forward, which is a term you'll see more in industrial applications, I think, than the aftermarket. But basically, when we're talking open loop, this means that the ECU is not trying to correct. So it'll send out, let's talk boost control. It'll send out a duty cycle to the boost control solenoid, and let's say we want 15 psi, 200 kPa, we get 220. The ECU is not going to do anything to pull that back down to its target. It's just a dumb system with no response. Closed loop, on the other hand, is where it's going to be looking at that error and then applying a change to the duty cycle in order to drag it back to our target. So that's where our PID comes in. But the key point here is that a good closed loop strategy starts with getting your open loop dialed in as close as you can to your target. And the reason we want to do that is that then any error that exists should, if we've done our job properly, be small, meaning that the closed loop control, the PID, doesn't have a lot of work to do to get us onto our target, meaning that it's going to do a better job. The other thing as well, which I always start with boost control, it's a complex topic, actually, boost control, but there's so many elements that come together to define how good or bad our boost control can be. I always like to start with absolutely no control at all. Just run on the wastegate spring and see what our boost curve looks like, because quite often we're going to find that the plumbing or the size in the wastegate is inadequate, and we're going to get this exponential rise in our boost as we get through the RPM. We can't fix that. We absolutely can't fix that.
Mechanical issues are always number one. And a lot of people are quick to look at software. We would get support calls at PCMTec saying, what's going on? I've put these numbers in, your software is not writing them in correctly, etc. And we'd be like, okay, well, let's put the software to a side for a minute. Let's just do a smoke test. Let's see is there any leaks in the system? Has the wastegate actuator been tightened up correctly? And there's all these mechanical things that are at the the base level that need to be set up correctly.
Yeah, I think this is where a lot of tuners that are coming through these days that really have no mechanical experience, and I don't say you have to be a mechanic in order to tune a car, obviously you don't, but having a good, thorough and broad understanding of the mechanical and electronic systems for tuning, I think really dials you into noting when something's not right. And I mean, I've been guilty of this myself. You've got a problem, let's say it's an ignition misfire, and you beaver away on the laptop keyboard in the comfort of the driver's seat of the car trying to fix a problem when the reality is there's no electrode left on the spark plug. It's a mechanical problem. No amount of work on the keyboard is going to fix it. So being aware of those problems that they can exist, I think is really, really important.
And we would see that in the oil and gas world as well, like massive crossover there with we'd have plant operators that were mechanics with a bit of an IT electrical background. Some were electricians, some weren't. And the ones that were very mechanical were quick to go to the mechanical side and look at that first. And the ones that, and then they'd see this layer of software on top and they'd go, well, the software's come along, I'm just going to look for errors here. Whereas if you go back a step and go, actually, no, it could be a mechanical issue, and start from the ground up.
Definitely. Yeah, I think it's really important not to get your blinders on and just sort of, zero in on one possibility, look at the wider picture.
So educating our users sort of along the way, we've had training manuals written, some very, very basic ones that are like, start with the mechanics, then look at the software, and then look at your open loop systems, then look at your closed loop, instead of sort of diving straight into the deep end and all the corrections turned on and something doesn't work and you've got to backtrack a very long way then to find where your issue is.
Yep. Now, just to sort of beat on about this PID for a moment, because we have mentioned it, I'll just give a real brief, and this isn't supposed to be an all-encompassing lesson on PID, but those terms, proportional, integral, and derivative, basically if you take them one at a time, that proportional gain, as its name implies, it's proportional to the size of the error. So the further away we are from our target, the more power essentially that proportional gain has to change the output and drive us towards our target. So that's great because it can correct an error quickly, but the problem is that this also on its own is going to end up with an overshoot or an oscillation. And it can't also, once we get really close to our target, the power of that proportional gain is diluted. So we'll never get onto our target with just proportional gain. The next one we've got is our derivative gain, which is related to the rate of change of error. So the more quickly our error is changing, the more power that has. I like to refer to this as a braking effect. Nice thing is by incorporating proportional and derivative gain, we can use a lot of proportional gain or a relatively higher amount of proportional gain and bring in this derivative or braking effect. And that lets us get to our target quickly, but the braking effect of derivative stops this overshoot and oscillation. Finally, our integral gain is relative to time, so this can drive us towards our target over time and get us right onto it. So using the three.
Your steady state sort of environment is definitely your integral, whereas the initial hitting set point is your proportional and derivative, and the three combined together very nicely.
Now, again, I don't probably have time to go into my strategy for tuning these for the likes of boost control or cam control. We cover that in detail in our courses. But something I just wanted to ask you, because you've come from that industrial background, there is an algorithm for calculation, I guess, equation is what I'm looking for. There's the term for actually calculating these gains. I think it's the Ziegler Nichols method. And I understand that it exists. Absolutely have never used this in the automotive tuning industry.
There is that method. It's a very old method and it does work very well in simple systems. There's some other more modern methods, and then there's just brute force approaches as well.
Okay. I guess my question is, in industry, were you using these equations to calculate the gains, or were you more doing it a test and try it and see?
We would do both. So we would model it and we would use things like, I can never pronounce it correctly, the Ziegler algorithm. And often you could actually just look at the oscillations and do it in your head and quickly go, I can sort of see the distance between the oscillations, and you could work it out. Oh, I'm off by this factor, and fudge it pretty quickly. But there was much more professional tuning packages for PID tuning where you plug it in and they could use brute force approaches, they could use different models, and then that would only often work in a system which wasn't changing that much. If you had large load changes, like a car with a trailer or without, etc., that's when it might start to fall apart sometimes. Or if you had a system where you had issues with the mechanical system, like stiction, like a sticky actuator, which just doesn't open, has a delay, a lag time in it, or it just can't move that fast. That's where those sort of methods would fall apart. And we were often working with old, dirty equipment with massive lag times, stiction, things like that, where these methods often wouldn't work. And we would sometimes resort to removing PID control and using a heavily based open loop system with just PID working in this tight zone only.
Yeah, okay. All right, we're so far off topic at the moment that it's almost a struggle to see our way back. So let's try and get back to that. At what point did you sort of think, hey, you know what, I really want to start an automotive business? And how did that all come about?
Yeah, so PCMTec started, officially, we were incorporated in 2017. I reached my limit probably of what I could learn in the oil and gas industry. I sort of started to find it getting a little bit more boring. I was wanting to write more and more software. There wasn't just that much software to write, and the business we were in, that wasn't a good return on investment. They made their money elsewhere. So I actually had an unfortunate but fortunate accident. I was driving my Skyline to the gym and I got rear-ended. Someone about 60 kilometers an hour on their phone into the back of it, broke the seat recliner in my chair. And luckily no one was behind me, and I think that saved me from severe whiplash. But that car was a write-off. I got a handsome insurance payout. But the car was always being pulled over by police. It was a real police magnet. And I thought, let's buy something that's powerful, fun, easy to modify, less of a police magnet. And what came to mind back then was a XR6 Turbo. So that's the Ford Falcon. That was the staple Australian family sedan back in the early 2000s.
So for our North American listeners, may or may not have heard of the Ford Falcon, Australian domestic market only, but probably have heard of the 4-litre straight six Barra engine that was in that vehicle.
Iconic Barra motor, yes, which is now being exported into the US. I don't know what numbers in, but they were in basically every taxi in Australia. So we had, they were sitting, you could probably find one in a bush somewhere. They were everywhere. But yeah, I picked one of those up, spent probably, I don't know, maybe $3,000 or $4,000 on clutch, intercooler, injectors, exhaust. There wasn't much, and tires, and that was about it, I think. And you could make a handsome 300, maybe 320 real kilowatts with no other changes on a standard unopened engine.
Okay. Let's talk about the tuning options and strategy for that, because essentially that's where PCMTec has come from. The Skyline world was pretty easy because I sort of cut my teeth on those vehicles as well, and the technology wasn't really that advanced. We're not talking about drive-by-wire throttle, variable cam control, no CAN bus. So it was pretty easy for most of the mainstream aftermarket ECU manufacturers to make a plug-and-play replacement ECU, very cost-effective way of giving complete control.
I'll give you a quick shout-out to Matt from Nistune. He actually worked for us for several years as an employee, and he was involved in basically making the OEM computer tunable for the Skylines back in the day.
Yeah, should have mentioned that definitely was another popular and cheaper option as well, sort of almost reflashing before reflashing was mainstream.
Yeah, but yeah, definitely much simpler back then. So yeah, the options were quite limited. There was two major companies out there. They catered to different markets. One was more DIY, but also professionals. One was definitely catering to workshops only. And their software was very expensive. It had better coverage at the time for the vehicles in Australia. I attempted to purchase it and was told, you don't have a dyno, you don't have a workshop, not interested.
What two software options are we talking about here?
So this was SCT and HP tuners at the time. So I purchased HP tuners back at the time. And back then it was reasonably limited with what I could do with the car.
Yeah, it seemed like at that time, HP tuners really, their focus was almost exclusively GM product.
They cut their teeth on the GM world, that's for sure.
Yeah, it's changed a lot in modern day. They've got a wide range of vehicles they support, but back then, yeah, the number of supported maps for the Australian domestic market Ford was quite limited.
I'll give you an example. I think they mapped maybe less than 10% of what was available in the ECU at the time. And I had my car tuned a couple of times and I was never really happy with the cold starts, all those little niggly things that would take hours and hours to dial in, which a tuner often wouldn't have time to do for what you're paying them. as a business, that makes sense. They've got a couple of hours, whereas they might need a week to sort of in winter to dial in your cold start. Whereas there were maybe 10 engineers at Ford that did that in a temperature controlled room. So you couldn't really blame them for not getting that right. But at the same time, I wanted it to be like OEM. So I just couldn't quite get it right. And I ended up with a brick DCU. And that basically term means an ECU, which is effectively a brick. You couldn't do anything with it. The car wouldn't start. And I was told to tow the car back to Ford and have it returned to stock. And I was like, I'm not going to have this. I'm bored. I've got some time on my sleeve. And I started tinkering around, and I thought, all right, how can I resolve this myself? Lots of just get on Google. I found a PhD written by someone on vehicle hacking, and they'd picked some Ford Transit van, I believe, or something like that, and described the security processes, reverse engineering, getting into the really nitty-gritty sort of how the computer worked and how to sort of get the ROM, the read-only memory, out of the computer and get it back in. And I started reading through that and going, wow, there's some worked examples in here. This is very similar to a Ford Falcon. And I wrote up a little proof of concept to sort of read and write the ROM from the computer, dump it out. It's basically a hex file, which for those of you who don't know, that's hexadecimal space 16. So you count from 0, 1, 2, 3, and you go A, B, C, D, all the way up to your 16 elements. And you get your hex file and you look at it and you go, I don't know what I'm looking at. But then you can disassemble it. And disassembly is where you turn hex or byte code into a computer language. So an assembler language, which is what the computer executes line by line. And then that's actually readable for someone who's studied computer programming. It's not easy to read. It's quite challenging. But you find a starting point and you go, well, I know I've changed this and this happened. So I'm going to go put 10 times that number in and see what happens. And go, okay, I know this is related to Spark, or this is related to idle RPM, etc. And you can sort of build a bit of a tree structure out of that and slowly map out the computer. A very, very time-consuming process doing that manually.
I'll just interrupt there for a moment. I've just gone through the process myself of, I would say, a very entry-level learning the WinOLS software, which is very popular primarily for European vehicles, but I mean, you can use it on absolutely any controller. And similar sort of process there, you can read out this raw hexadecimal file, which, as you say, is kind of pretty much meaningless. But the power really of WinOLS is being able to visualize graphically the shapes of the raw numbers. And when you sort of get that pattern recognition, you know, well, hey, look, an ignition table looks generally like this, or a driver demand table looks a bit like this, and you're sort of like, oh, yeah, that's what that's going to be. And that's the process sort of I've been using for reverse engineering factory ECUs. That in and of itself is not bulletproof. You're not going to be able to use pattern recognition to find and define absolutely everything. And we use that term as well, define. You know, even if we look at an ignition table, we'll find the table. We know it's however big it is, X by Y, and so it's got that number of rows and columns, and we can see the axes there, but the axes won't be RPM in 0 to 7,000. It's a raw number we have to apply scaling to. Likewise, the load, likewise, the ignition timing. Sometimes there's patterns for those scalars that make sense. Other times, there's no way you're going to guess. And this is where people use A2L files or description files, which normally sort of come through some backdoor from Bosch or Siemens or whatever the controller manufacturer is into the aftermarket. So I've put that piece of information out there. How does that coincide with what you were doing?
So basically, we were lucky in the Ford world. They use floating point numbers for most things, which is basically a decimal number like you'd see in Excel. So you could go, that literally is a Spark timing value. So I could just look at it and go, wow, that is a Spark table. It made things a lot easier because the process they used dealt with floating points quite well. But in Bosch and many other computers, that's not true. And you have these scaling factors. You would see a nice shape, but the number might be 45,000. And you go, well, I'm not running 45,000 degrees of Spark timing. It doesn't make sense. But the shape looks correct. And you could backtrack and work out scaling factors and things like that. But we mapped out one car, which is my car. And when I say we, I met my business partner on the PCM hacking forums back in the day. And we were just playing around, just looking at things. And we thought, well, this is actually not that hard for us. He had a background in, I think it was software engineering, but it wasn't called that back in the day. He'd been working with computers since the late 70s at Intel, IBM, places like that. So he was very, very good at assembler. And I found that out sort of slowly by talking to him, realizing how experienced he was as well. And we quickly met up on the forums and sort of started making this very small, basic software package. We put it up for free, and people were like, wow, you guys really did that quite quickly. And we've been asking for some of these tables or maps to be added for years, and we were offered money. And we're like, we'll go find that, and we'll find it in an hour and put it up, and that would just blew some people away. And we were like, okay, there's actually a problem here, and we can solve this problem, which is the typical business case: find a problem and solve it.
So there's bigger companies, SCT and HP Tuners, massive companies with a lot of staff, but as often happens with these bigger companies, too slow to sort of respond to customer inquiry, and maybe their focus was in other areas where you were solely focused on this one product?
Definitely. The Australian market was smaller. The cars were older at that time. It wasn't their core focus. I don't blame them for not focusing on that. But for us, being Australian, and it made sense. This was a hobby as well. We had time up our sleeve. My business partner was retired, so it wasn't very hard to convince him to work for free.
Passion project.
Yes. And then, people were like, wow, you can add these extra features and things like that quickly. And we went to a drag meet at Heathcote, probably in late, it was either, I think, 2017. And we met up with probably quarter to a half of Australia's largest Falcon tuning community at that time. And the word had got out that we've been building this software package. And they're like, do you want to try it out? It's free. We'll just give it to you. You can use it. You can do what you want with it for 6 months, and then we'll see what happens. And very quickly, people were happy with it. They could talk to us, get direct support fast. We could find parameters that had been holding them back for years. And then we turned it into a business. And so I got a year unpaid leave from my work, which I did not return to afterwards, which was a bit of a gamble.
So I was going to ask you, that sounds like you're putting a lot of work in. So you weren't actually working the main job. This is on your year of paid leave. You're doubling down on this.
Yeah, so we did a bit of work on the weekends and stuff like that where we could fit it in after hours. I didn't have any children at the time, so I had spare time then. Yeah, we got to a point where we're like, okay, this is saleable. We can make money out of this, but we're going to need to put in full-time effort on this. And that's when, I left my job and basically went, full-time into it. I convinced my wife to let me work for about a year without income. And that was still the time frame. We're like, we have to make money by then. Otherwise, I'm going back to work. And my work was lucky. They were very, they basically said I could come back at any time. They're like, please don't leave. But
so you had that safety backstop of the worst happened and this just didn't have any legs. You had something you could go back to, which I assume probably paid pretty well too.
Yeah, we'd saved up some money for the mortgage so we could cover it for that time. My business partner, Daryl, he was retired, so he was in a good position as well. He didn't need the money at the time.
I'm interested at the start of this sort of project, playing around and making this free product, was it always the game plan, hey, there's a business behind this, we can monetize this at some point, but we're just going to get enough runs on the board and prove proof of concept before we go that way?
Yeah, basically, we basically gave ourselves that year window of let's just prove that this is actually business viable. We've got the skills to do it. Can we actually execute this? Coming from software backgrounds, Daryl had a management background as well, working at universities. I myself was just a pure software engineer at the time and had worked under teams, and I'd worked with people under me, but I didn't have a business background. So I was very quickly learning how businesses worked and the simple look for a problem and solve it in a way that can make money. And that was the core business.
Yeah, that makes sense. Just interesting on the sort of scalability of this, because you mentioned the Australian market is small, and probably the reason that HP Tuners, SCT, weren't overly keen to double down on their efforts with the ADM, Australian Domestic Market models. From your perspective, you've got I think about 25 million people in Australia, about 330 million in America. How did you see the market being big enough to support you, or is it just the fact at this stage you're two people and you could run lean?
With two people, your wages are quite low compared to 100 people or however many work for the larger companies. Our overheads were working at home. I got a subsidised office through an incubator program at Adelaide University. And then we got our first employee probably about a year into the business when we were starting to make money. And that's when we're like, okay, we can pay ourselves a wage now. And that's when we're like, okay, there's enough people using this product. The Australian market, whilst much smaller than the US market, it can sustain, 5 employees quite comfortably. And we slowly grew it into that size. And that's sort of where we tapped out on the Australian market. We're like, okay, this is how many cars there are, this is how many workshops there are. And we captured most of that market over about a 2-year period.
Would I be safe in assuming as well that you'd be more appealing to the Australian tuning industry on account of, I'm guessing, that they can get tech support pretty readily within their same time zone, which I've always struggled with when I'm dealing with the likes of EcuTech in the UK, HP tuners in the US, etc. That can be problematic.
Yes. Yeah, so having the support available, and they could talk directly to the programmers and developers themselves, that was a huge win. And we could turn up to workshops and do site visits ourselves. And you can win a customer very quickly with a face-to-face visit, basically, or same time zone phone calls. We found that very beneficial. And then with software that covers more parameters that are mapped, there were 2 big selling points in the early days. Like basically we could map everything or close to everything. And then we had another sort of watershed moment, which is when we're like, okay, let's start really tinkering with this and adding some extra features. So we weren't just mapping out the OEM system, we were adding aftermarket style functionality to the computers.
Okay, I'll stop you there. We'll talk about both of these separately. I just want to come back to, you mentioned you could map everything or close to everything. And this is one of those areas where be careful what you wish for. The reason being that compared to an aftermarket standalone ECU, a factory controller may have thousands, if not tens of thousands of different tables and parameters. The reality of which is for a basic tune, let's call it a stage 1 tune, which is a term I absolutely despise, but for simplicity, let's call it that. So no bolt-on modifications to the car. We're just optimizing fuel, ignition, cam, etc. for what we've got there. We may only need access to 10, 15, maybe 20 different maps or parameters. And I guess when you've got access, let's say if it was everything, that can be so daunting, so overwhelming. Sometimes I think less is more. Granted, if we start making significant changes to the volumetric efficiency of the engine, let's say cam swap, maybe different capacity, changes in compression ratio, head porting, dramatic changes to the base engine, then yes, you're going to need access to more and more parameters. But yeah, what's your take on that?
So we basically saw it as there's people out there that want to tweak their idle, or they might want to put their engine in a speedboat and they just want to turn security off. They don't need access to much at all. And we broke the package up into 3 different levels. So a basic, our enthusiast package, our professional, and our workshop package. And these would give them different levels of access to parameters. And then we would divide up different view levels. We would work out what are commonly used, what aren't. Like tuning your air conditioner probably isn't at the top of your list, whereas your ignition and spark, your fuel scalers, your manifold pressure scaling factors, so you can change your sensors, etc. are. And we would put these into categories and make them easily accessible, and would hide away a lot of the other more intricate stuff. But it was still there in the background, and you could change your view levels and hide these, or you could just buy the cheaper package that didn't have access to them. And that was a very good approach to sort of dial it back and make it appear. It might seem like head in the sand, but it would definitely make it simpler. And you really didn't need to know a lot of the extra funky bits and pieces going on there. But when you did have those strange problems, or you really were changing your air conditioner or something, you had access to all of those set points.
For those 3 or 4 people in the world that want to change their air conditioning, you've got them covered.
You would be surprised the number of people that do weird and wacky things, fan set points and all these different dead bands and things like that. Cruise control, how aggressively it ramps up and down. There's different PID loops even for your cruise control, and people wanted to play with that. And especially when they change throttle bodies or they have turbos that come on very early. Well, those kind of things actually are almost critical to make the car drive like OEM.
Yeah, it makes sense. Yeah.
So we covered a lot of those sort of things as well in the workshop edition.
Okay, so probably the more interesting part, which you alluded to just before, is you've also added features that weren't available in the OE controller. Can you dive into that in a bit more detail, explain what sort of features you're talking about and how that works?
So I guess our mission statement now really is bridging that gap between the aftermarket and the OEM world, where the computers are so powerful and have so much spare space. You effectively can make them into an aftermarket computer. Just whether can you do this in a way that makes business sense and makes money. So we would look at customer requests. It was all customer driven. They go, I want to do this. An aftermarket computer can. I can't figure out how to do it in the OEM computer, or it's too difficult to do it. So we would go and add different features like flat shifting, so where you don't lift your foot off the throttle, you would cut the injectors during a shift. You would have different variable boost levels. You could have, that would be adjustable on the fly. You wouldn't have to go reflash your computer to get a different boost level. You wouldn't need an aftermarket boost controller. We would add things like boost by gear, which is sort of like if you're going to go on a race on an unprepped surface, you know the car's making too much power. You can change the tune to basically make far less boost in the lower gears and bring it in as the car goes faster. And those sort of things are quite trivial to add, but they were very common in the aftermarket world. And being able to do that and in the OEM computer and be able to configure that using hardware already in the car. So your cruise control buttons, for example, we use those to adjust the tune or boost level. We use spare analog inputs for a flex fuel sensor, and that's to use different fuels such as E85, which is an alcohol fuel, mixing that with petrol or gasoline for the US people. The different quantities, normally you'd run all E85 or you would run all 98, but some people would like to mix it. And then you might end up with 5 different tunes you'd have to flash into the car at 3 or 4 minutes, time consuming. You're at the track, do you really want to be flashing a car? Whereas a flex fuel sensor just adjusts it automatically on the fly. And so we could add these very common aftermarket features in, and that meant we could raise the price of the product and make it still much cheaper than an aftermarket computer, but cover a large percentage of the common requests.
I think it's just there's a couple of things I want to dive into here in a bit more detail. It's probably worth mentioning here for those who are wondering, well, why wouldn't we just go to an aftermarket ECU? And it kind of comes back to what I was talking about with the Skyline era of vehicles. At simpler times, particularly the lack of CAN bus integration that we had back then, about, let's say, year 2000. These modern vehicles, particularly when you've got electronically controlled automatic transmissions, the CAN bus integration is quite significant. And yes, we could take away the factory ECU and fit a Link, Haltech, Motec, whatever, and actually get the engine to start and run. But the gearbox isn't going to change gear. Probably a gauge cluster isn't going to show speed or RPM, and probably half a dozen other things aren't going to work. It's not to say it's insurmountable, but does require a lot of work by the ECU manufacturer to get that integration to work just like stock. So it's been difficult, in a lot of cases impossible, to switch to an aftermarket ECU unless you're stripping the thing bare and turning it into an outright race car. So reflashing has become more and more prominent with these later model vehicles because it is a cost-effective solution. So I just wanted to mention why we sort of would not go down that aftermarket standalone route.
Yeah, so for a dedicated race car where you're spending $100,000 on an engine and suspension combination, spending upwards of $10,000 on a Motec and all these different translation modules to run the ABS and the other 20 computers that are in a modern vehicle, that makes sense, right? You've spent this amount of money on a car, it's a proper race car. You would almost be silly not to. But you can run, a 6-second quarter mile with an OEM computer. It's just what level of creature comforts do you want to keep in your car? Do you want your air conditioning and your windows to still work? Do you want your gauge cluster to still work? Or do you have to buy translation modules or pay for advanced firmware to make that stuff work? In older cars, not a big deal. In newer cars, a much bigger deal. And now the biggest thing is gearboxes. So, for example, in a modern 2018 plus Mustang with a 10-speed gearbox with 3 intermediate shafts, the logic behind controlling that is as complicated as the engine. essentially. There are so many different permutations of clutches and brake drums and things like that, that building something to emulate that would be so expensive that it probably would never make money on it. And that's why I don't think you will see an aftermarket computer run a 10-speed gearbox in the near future. You'll see piggybacks and things like that where they might intercept CAN bus and things like that. But unless you're going manual or like a dog box, like a sequential shifter or something like that, you're kind of stuck. If you want to retain that original factory shift pattern and gearbox, you need the OEM computer.
This sort of begs the question then, it's a question I ask myself probably once or twice a year, and the line, in my opinion, gets grayer as time goes by. But from your perspective, at what point is the right time to switch from a factory OE controller to an aftermarket standalone?
I would say when you're building a race car, basically a dedicated race car, or something that is not really a street car, or the amount of money you've invested in it dedicates that, and you don't need those extra things. You no longer have the factory gearbox. You no longer have the factory ABS system. You need very advanced, fast traction control systems. That's sort of when I would say that it's absolutely appropriate to go down that route. But if you don't want to do any wiring and you don't want to outlay that money because you've only spent $3,000 or $4,000 modifying a vehicle, that's when it doesn't really make sense to do that, in my opinion. Yeah, it sort of becomes a cost issue, really, as well as what functionality do you need.
Yeah, I think I wholeheartedly agree. A dedicated race car, particularly when you're getting rid of the automatic transmission, yeah, it's probably a no-brainer. Another element you get with some of the better aftermarket ECUs is motorsport level data logging, which is really critical in a race car to improve both the chassis and the driver. So I think that makes sense. But yeah, to sort of come back, I mean, probably when I first got into the industry, or maybe halfway through my career, it was a pretty defined line of where, with most vehicles, it made no sense to stick to the factory ECU and we'd switch. And as time goes by, just companies like yourself are making that decision much more difficult to make. Right, coming back to the other question I had here is adding these additional features, these software features, launch control, flex fuel, etc. I mean, how on earth do you do that when you are stuck with the factory controller architecture?
So essentially, most of it is software. You've already got all the outputs and everything you require. So you're manipulating ignition timing for rolling anti-lag. For boost control, you've already got boost control built into the ECU. So you're adding new code that runs these systems and intercepting basically where the original code worked. It will jump to your new code, and then you'll intercept it and allow the user to adjust it, maybe through the cruise control buttons. You use additional inputs like vehicle speed to adjust boost level, etc. And you'll basically write your own custom firmware and insert that into the original firmware. And firmware is another name for basically the ROM, or the read-only memory in the computer. And we were effectively writing code like an aftermarket computer company would write, but we're putting that into the OEM computer.
Is there a limit to this then? If we take things to extreme, I mean, if we look at the US domestic market, late model Ford products, say Mustang, for example, they're an incredibly complex ECU. I mean, from my perspective, it looks like Ford looked at how every other OE manufacturer was controlling an engine and said to themselves, hold my beer. I'm going to come up with the most unique, different left field technique possible. Obviously, they've got their reasons. I don't know what those might be, but it is quite a unique strategy that they've got. And for us in the aftermarket, that with all these mapped points makes it very, very complicated. Could you sort of decide, hey, you know what, let's just wipe all of that and turn it into a basic speed density based system like we would see in an aftermarket ECU?
You definitely could do that. Other companies have done that as well. The main issue comes around emissions control. So if you've got a street car, to meet emissions with fully variable intake and exhaust timing, valve timing up to 40 degrees on both, so that's variable overlap, intake and exhaust, you need a very complicated model to make that work and work like precisely within a few percent and meet emissions at all times.
The point here being that as that cam timing moves and they move independently, hence the overlap changes, the volumetric efficiency of the engine changes. So if we're dealing with one speed density table, it's only going to be accurate for the combination of intake and exhaust cam timing that it was mapped at. And if those don't match, all bets are off, correct?
Exactly, yeah. So if you have static cam timing, and when I say static, like it's moving cam timing, but let's say for a given load in RPM, the cam timing tracks this map. Your VE you should be able to build a model in essentially a single table for that. If the cams move out of that zone though, your VE changes and that map no longer works. And that's where your short-term fuel trims will come in and correct for that error. However, there'll be a lag time there and your emissions will go out. And the way that that's done in lots of other OEMs is they might pick 3 or 4 volumetric efficiency tables. It's reasonably simple to calibrate compared to, if you go back to a car with no variable valve timing with one map, it's very simple to calibrate. I spoke to an ex-Ford calibrator who said when they came up with the Ford system, it was intellectual masturbation.
I've heard that term a few times, yeah.
They had looks like a statistician designed it. It works fantastically. It's not easily calibratable though, because it wasn't designed to be. It was designed to be calibrated on an engine dyno with every sensor under the sun connected. You might have 10 engineers there for 6 months dialing this engine in. You can't do that in 3 hours with your workshop. But if you're only making small tweaks, you absolutely can do it. They use up to 25, as you said, mapped points, which is effectively a volumetric efficiency table. And they are designed for the different modes the engine will run in, because it won't run static cam timing for a given load and RPM. You'll be in fuel efficiency mode. You'll be in high temperature over temperature protection mode. You'll be in optimum power mode. You'll be in, there's all sorts of these little different zones that they'll run the engine in depending on what you're trying to do. And mostly that's around emissions control. So you've got a 5-litre engine making a lot of power that meets current emission standards, which
it's no mean feat.
It's quite phenomenal if you think about it. There's no real way you could do that without these crazy valve timing adjustments or other, like turning cylinders off, etc., and things like that. So they've done it in a way that works well, but is difficult to calibrate because there's so many points. And then they also run intake runner controls. So they'll run like a butterfly on the naturally aspirated cars, which then doubles the number of points, because these are basically to change the airspeed going into the cylinder at sort of partial throttle opening. You've also you're trying to generate like a exhaust gas circulation effect to dilute the intake charge to effectively get better emissions as well. And these different modes mean you have so many maps that need to be calibrated to make all these modes work. Though in the tuning world, when you've just changed maybe a supercharger pulley, or you're just adding a different fuel that has better knock resistance, and you're just changing spark, or your VE doesn't really change much, and you might find it's only in one small zone you have to tweak. So you might be making 5 to 10% changes, and you can data log which map point is active, and you can figure this out.
Just to come back and clarify a couple of the bits we've been talking about here for those who maybe aren't sort of super up to speed with Ford and late model reflashing in general. If we dull all of this back to an aftermarket standalone, even with variable cam control, generally we're dealing with one single volumetric efficiency table, and kind of like what you mentioned there, we're assuming that we've mapped our cam timing, and the cam timing for a given combination of load and RPM is always going to be the same, and if that assumption holds true, then our VE table is accurate. If we look at how some of the simpler, older OEs did this, let's say Honda with their K series engines is a good example. You've got an intake cam there that can be mapped through 50 degrees of movement. And we've also got high cam and low cam with their VTEC mechanism. So they went and sort of decided, all right, well, we're going to have volumetric efficiency tables at 0, 10, 20, 30, 40, and 50 degrees of cam angle. And we're also going to have another set of those tables for high cam and low cam. And we're going to do the same for the spark. So it gets a lot more complicated. The idea there with Honda's thinking is, once those are all mapped, assuming all of those VE and spark tables are accurately mapped for that cam angle, then if the cam timing moves around, it doesn't really matter because it's going to switch to the relevant table and it's going to be accurate. And Ford sort of took this one step further, maybe 100 steps further, I guess. And now, rather than VE tables, we've sort of got a very complex equation with coefficients that go into calculating VE, correct?
Yes, so it's not even a number that really represents airflow. It's a quadratic function.
Quadratic equation, that's the term that I've been searching for the last 5 minutes.
They hated in year 9 maths. It's quadratics everywhere, and they really are useful. They model the volumetric efficiency, and so you actually have not just a single table. You have an intercept, a slope, and your different coefficients.
All sorts of ugly things that make no sense to us as tuners.
Yeah, and even people who did maths and understood it, that just look at it and go, this is not something I can just fudge. I need a calculator for this. But if you are making small changes and you know what you're doing, you can actually make incremental changes, especially with fast flash times. So with PCMTec, we've got our flash times down to about 12 seconds on a modern Mustang, so an 18 plus Mustang. So you can sit there and just fudge your way through it. You're not waiting 15 minutes to flash the car, but using a calculator or doing a data log and inputting the data into a calculator and outputting it, you can get pretty close in the ballpark in a few runs that way.
I just wanted to take a moment out of our interview with Roland here and talk about a course that we're offering that I know is going to be perfect for anyone who's enjoying this interview, and that is our practical reflash tuning course. As we've already talked about with Roland, the process of tuning a factory ECU is quite different to tuning an aftermarket standalone, and I know that even experienced tuners do struggle with this transition. Well, the practical reflash tuning course is going to be perfect for anyone who wants to learn how to tune factory ECUs and get great results. We talk about the basis of how a factory ECU works, as well as how reflashing works. We also cover data logging, which is so critical to getting good results when you are tuning a factory ECU, particularly when you often can't make live tuning changes. We then break the entire tuning process down into the HPA 6-step process. This is a process that can be applied irrespective of your tuning platform. Maybe you're using PCMTec, maybe you're using HP Tuners, EFI Live, or Cobb, or anything in between. It doesn't matter. It also doesn't matter what vehicle you're tuning or whether it's naturally aspirated, supercharged, or turbocharged. The 6-step process is completely applicable. By following this process, it breaks it down into individual bite-sized steps that are relatively quick and easy to complete, and in no time you've got a completely tuned engine, and you're going to have the confidence that the engine is producing great power, great torque, and most importantly, great reliability. By following that 6-step process, it also ensures you don't overlook any steps that could waste time, waste money, or even potentially do expensive damage to your engine. Once you've gone through the body of the course, we then move into our library of worked examples, which is an informal walkthrough of that 6-step process. You can watch that being applied on a variety of different cars, as well as a variety of different tuning platforms to give you broad experience. You can get 50% off that particular course by using the coupon code PCMTec50, and we'll put a link to that course as well as the coupon code in the show notes. Let's get back to our chat with Roland now. All right, let's come back a couple of steps. Maybe if you could now we've got a bit of an idea of the business itself, maybe if you could give us the 30,000 foot view of where PCMTec is today. So I don't think we've really got years in business so far, but number of staff and products offered at this point, and your location in Australia.
Yeah, so we're a remote company. We're primarily located in Adelaide, South Australia. So we have an office here. There's 3 of us generally in the office here. Daryl, the other owner, he's in Victoria. And then we have the people spread out around the country. We've used contractors, etc. So we're set up to work entirely remotely, but our head office is in South Australia, and that's where the company is incorporated. And we started back in, I believe, early 2018 was probably when we made our first dollar. And then we grew very slowly for the first 6 months as we got our name out there. And then we sort of had those watershed moments where we went to drag meets, met large volumes of customers. They became advocates for us. And they almost became salespeople for us in a way by saying, guys, what are you doing? Use this software. It's faster, local support, etc.
Word of mouth and success on the drag strip or the racetrack is definitely a very powerful way of growing a business.
Yeah. And the product really does have to be better. Otherwise, like, why would you use it? Or at least, or a lot cheaper. Our price point was probably fairly similar, and with our custom operating system is more expensive, but it adds so much more that the competition doesn't offer at all. So it became a bit of a no-brainer. After a while, it was the only option really to use. And so that helped fund enough employees to start building out the business to go, okay, the Falcon's not made anymore. Ford Australia doesn't really exist anymore. No more Barras coming along. There's no more Commodores coming along. What are we going to do? And the logical step was the global market, which is the Ford Mustang, the Ford Explorer, the F-150 trucks. I believe they sell more F-150 trucks than they do any other vehicle. So that's not just trucks, that's all vehicles.
The scale is incredible.
Such an insane amount of, I believe it's something close to like 900,000 are sold a year or something. Whereas in Australia, they sold about 30,000 Falcons at their peak. And they were taxis as well. So the market is just ginormous overseas. So, okay, look, this business has a lifetime on it, right? Like eventually people are they'll keep tuning Falcons, but there'll be less of them. Aftermarket solutions will become better. The cars will become more expensive and scarce, etc. So we go, okay, let's reinvest this profit and we'll basically build a software product basically the same as the Falcon product in terms of custom operating system, extra features, etc. And also with the goal of adding every parameter that we could possibly add, but also dialing back the view levels to sort of make it manageable at the same time to cover that DIY market and the workshop who really does need everything. And the Mustang was the number one that we started with. And we found that Ford had used a fairly similar platform across the board. So a Ford Explorer, F-150, Mustang, they all use a similar operating system. We do one. We've written some clever pattern matching scripts and decompilers and things like that over the years. And we can go pick up an F-150 calibration and map it out in a couple of minutes automatically. And that's based off a Mustang, even though they're not the same car at all. And the engines whilst they might use the same engine, they have different firing orders. Some use MAP sensors, some use mass airflow sensors. There's differences, but not enough to make it difficult for us to scale and build that out. And we've been doing that over probably started work on that early 2021, so the last 3 years. And we've launched that into the US. We have customers in the US now, UAE, so Dubai, covering the Gulf and the Middle East region, UK, Germany, and then, lots of other smaller companies, even South Africa, we have customers there.
Right. I guess the question that pops into my mind here is, obviously when you started, there was a very clear need for a product because the mainstream players, SCT and HP tuners, were largely ignoring or definitely not developing on the Australian domestic market model. Now you're kind of more moving, as I would say it, onto their turf. How do you now differentiate yourself from these two big and established players that have been supporting that platform?
So they cover a large number of vehicles. So whereas our focus is solely Ford, and we've picked a vehicle set, gasoline only, no diesel, etc. And we've really honed in on that one zone and gone, we're going to really do this properly. We're going to add every parameter we can. And then we're going to add this aftermarket functionality. So we're going to bridge that gap to the aftermarket world. And some companies have done little bits and pieces of that, but not to the level we have. And I don't see them having aspirations to do that either. So that's sort of our point of difference there, price point as well. Because we're a software-only company, we don't build any hardware or make any hardware. We can sell our software for much cheaper as well. So we can come in at a lower price point and differentiate ourselves in that way as well.
That sort of leads nicely into the next point, which I think to a degree you've just answered. When it comes to reflashing solutions, as I said, there's two business models. One is a software package, which is a user interface, maybe a data logging package as well, and the ability to read, modify, and then write, usually with a hardware interface that's going to go between your laptop and the OBD2 port. The other solution, which the likes of SCT favour, is a hardware unit unit, which is VIN locked to each particular car. So you need one for every vehicle you tune. Generally, that's going to be a more expensive solution. Offers some potential benefits in that the end user can usually store multiple maps on that unit, swap them or flash them in themselves, and maybe even data log and send data logs to the tuner. So you've gone the software route. How did you sort of weigh up the pros and cons of the two models?
So in the early days, everyone was using SCT handhelds in Australia, and they're like, we've got 4 or 5 different tunes. How are we going to solve this? Not everyone wants a laptop. And we go, well, that's where our multi-tune functionality came in, where we would literally put multiple tunes into the same file on the same computer. You would flash it once, and you could change the tune using the cruise control buttons. And then suddenly you didn't need a handheld flasher to change the tune anymore. That was providing a customer went to a workshop, they did all the work, they flash it. If they did need to make remote changes, they would need a laptop. And then we went to the US, and they're largely remote tuning. So they do use a lot of handhelds still. A lot of people don't want to use a laptop or have a laptop on hand, whilst some do. So we've tried to remain hardware agnostic, where we support lots of different cables. If someone goes belly up, it's like there's 4 other products out there you can flash a vehicle with. But for those who do want to use a handheld, there's 2 companies we've partnered with to provide one. One's Livinois with their MyCal, and the other one is SCT with their X4. So our software can export to a format that those products can use. So tuners who are already using SCT can use our software with their software and basically load a PCMTec tune with all the aftermarket functionality onto an X4, mail it across the country. And that sort of solves that hardware problem where we don't have to build hardware anymore. Well, we don't have to think about building hardware, which we never wanted to do because our core competencies is really software. But also there's alternatives out there like the MyCal. Those who do want to use a laptop, they can use a J2534 cable, which is a generic standard. There's probably 5 or 6 major ones out there. So there's lots of different options there to basically either use a laptop with various cables, or for those who do want the handheld with multiple tunes on it, if you had, say, drastically different changes to your tune that the multi-tune wouldn't encompass, for example, you could use that, or mostly for data logging, though. Having a little screen with an extra data logging display, lots of people like to see that, and that's one advantage of that.
Am I right in sort of guessing that that's going to be mostly useful, though, for those who are already so indoctrinated into the SCT sort of ecosphere? It's obviously going to be a more expensive solution than using the likes of, I assume, the generic dongle. Something like a Tactrix cable is going to work with your software?
Yeah, so the cheapest option is always a laptop with a J cable. If you're competent using a laptop, the data logging package on a laptop is better. You can do map tracing, like live map tracing, similar to an aftermarket computer. You can log up to, I think there's something like 45,000 parameters you can data log. You can visualize and view all of this on your laptop. It's a better solution for those who are doing the tuning themselves, in my opinion. It's also much cheaper. But if you're an end user and you just want to tune and you've just paid for a tune and you're not interested in any of that stuff, that's where the handheld solution really works. But it is more expensive, obviously.
Yeah, makes sense. Okay. Just in terms of the reflashing process, one of the things that I know puts a lot of people off when they're transitioning initially from aftermarket standalone to reflash is that, with some notable exceptions, generally when we're reflashing, we're not making our tuning changes live. And by that I mean you don't have the car sitting there idling on the dyno and make an ignition timing change and that becomes effective immediately. Now, yes, there are some notable solutions where they've kind of done some pretty spectacular work and allowed live tuning of certain tables. Interested on your take on that. Are you supporting live tuning, or is it only reflash only?
So we looked at live tuning, and whilst it would be possible to do it, and some people have, most of the time the changes you're making are complicated enough that you need to do a data log, review the data log, really figure out what you need to change, and then change it. So reflashing is not an issue. Also, the time frame to do the reflash is so fast now. I'm talking 12 to 30 seconds. It's not 20 minutes anymore. However, there is a use for live tuning, and especially with older cars, there was when they were so simple, you could literally just hit page up constantly and change your ignition timing, hit MBT on the dyno, and you're done basically. But now it's complicated enough that doing that is uncommon. But if you wanted to, there are actually solutions out there that let you use OEM debug functionality to lock timing, so spark timing, VCT timing, and lock it live. So you say you're on the dyno, you're at a certain RPM and load cell, you can use a tool like ForScan, for example, and you can lock the timing and you can adjust it, find your MPT, that's your maximum brake torque at that point, and dial it in that way. So you can actually do live tuning through other tools that are incredibly cheap if you wanted to.
I sort of came from that same mindset that the lack of live tuning was a bug. And as time's gone on, and I've done a lot more reflash tuning, I actually find it now it's a feature rather than a flaw. As you mentioned there, it's quite complicated, the changes you're making, which is reliant on data logging. And I'll give an example here. We do a ramp run on the dyno. Well, standalone or factory ECU, I'm not making timing and fueling changes during that ramp run. I mean, obviously that's ridiculous. It might be a 8 to 10 second pull on the dyno. We don't have the time to do that. So we're reliant on monitoring everything, looking at our data logging later and saying, we're rich or lean here. Maybe it'll take some more timing. There's a little bit of knock. We pull some timing out. So then we can make a host of changes basically throughout that rev range under those wide open throttle conditions and reflash and go again. So really, I don't see it as a dramatic drawback. The other thing that's easy to lose sight of is when we are dealing with reflashing a factory controller, short of making some of the dramatic changes to the engine configuration that I mentioned before. Under most conditions, we might be doing an air intake, exhaust headers, those sort of basic bolt-ons. And we're not starting like we would with an aftermarket standalone with no calibration. We're starting with that factory calibration that was ideally perfect for the base engine. And a lot of it won't need any tweaking at all. Maybe your idle, your cruise areas, those will all be fine. And generally, we're focusing almost exclusively on the wide open throttle area. Now, obviously, we stick a big cam in an engine, and that dramatically changes the VE, and all bets are off. And then, yes, it's going to need a lot of work. But even then, some of the tools we have available with data logging allow us to use the likes of histograms to gather a large amount of data in terms of maybe our short-term and long-term fuel trims, and gather that through a large range of load and RPM, and then apply that to our tables and sort of correct large errors very, very quickly. And usually 2 or 3 iterations of applying this logged histogram data, assuming the data is good quality, very quickly zeroes us in on an ideal tune. Do you agree with that?
Yeah, absolutely. You can do quite simple mods to a car, and you don't really need to do that many iterations. And then when you do have a complicated car, for example, like you've got a supercharger added or something drastic done to the car, that's when you do need to spend that time. And that's when the ROI, like the return on investment, so you might have 3 or 4 hours to do this car, becomes an issue because you can't do that amount of tuning in that amount of time. And that's where some businesses become unstuck. And I usually recommend to people that are starting out that if you're going to do things like that, you come up with a kit. So maybe a supercharger, certain injectors from known reputable brands, or even if they are unknown, but as long as you pick something that you've tested and you always use the same set, you might be able to spend weeks dialing that calibration in, right? Which you would lose tremendous amounts of money on for one customer. But if you then package that up and sell that same kit to multiple customers, you only have to make minor tweaks each time along the way. And I would argue that if someone came in with XYZ injectors on their car, the time to dial them in, you probably are better off just pulling them out, putting in your set that you sell and and you have good data for and you've already spent the time on, put them in, you've saved tuning time, you've guaranteed they're flow tested, the cylinders are all balanced, the customer's going to have a better result and everyone's going to save money in the end.
100%. I'll sort of just reference this back to my old tuning business, and we sort of started with JDM vehicles, but quickly realized that the customers we were dealing with there, not to tar everyone with the same brush, but there were a lot of champagne dreams and beer budgets, and you sort of got sick of dealing with cars that came in held together with race tape and zip ties. So we sort of transitioned in the later years to the Ford, and actually predominantly in New Zealand it was the GM product that people were frothing over modifying. And so this was the LS1, LS2, LS3 based Holden Commodore, so Australian domestic market, but essentially the same platform is very popular in the US. And we had our own demo car, and we sort of went through stages of upgrades on that. The first stage was essentially tune only, no mechanical changes, then headers, exhaust, intake, and then the final stage was put a big hairy cam in the thing and really let it eat. And we did exactly what you're saying there. Simpler controller, simpler engine than the late model Ford stuff. But for all intents and purposes, I'd sit on the dyno for a day, dialing everything in, go out on the road, spend another few hours on the road, making sure it drove absolutely perfect. I daily drove the car. I could make sure the cold start was good in summer and winter. And then we'd move on to the next stage. The benefit of this is we had a staged upgrade package for these vehicles. We could tell the customer to the dollar what it was going to cost. We could tell them usually within 1 or 2 kilowatts what it was going to produce. And then the benefit for us as a business was usually, particularly for the stage 1 and 2 upgrades minus the cam, it would literally take longer to put the car on and off the dyno than it would to make the tune. We'd basically load in the calibration, which we knew was going to be there or thereabouts, run it up, maybe make 1 or 2 iterative changes. That was it, take it back off the dyno, the job was done. That for a tuning business is the way to make money. Now, the customer is paying a reasonable chunk of money for that tune, and you might say, well, it only took 5 minutes. How can you justify that? Well, the reason I justify that is it wasn't 5 minutes. It was the weeks of work that I had done. Coming to the late model Ford stuff being that much more complicated, I sort of see it's going to be difficult for the home enthusiast who wants to make substantial changes to really do that and dial their tune in accurately, because it could literally take a week of dyno time. And that sort of really favors these businesses that are going to specialize in, the 5-litre Mustang and upgrade packages, because again, they can put that time in, get that tune really on point, and then sell it over and over again. So sounds like you agree with my sort of tuning philosophy there.
Absolutely. And then you can come up with lots of different permutations and iterations of these. So you might have, we've only done these injectors and we've only done this supercharger, but we've got good calibration files of both. We can merge them together and come up with something very close first go. And that's where we use our parameter files, which are basically like a preset template, which you can export in PCMTec to give you as small or as big a base file as you'd like. And that can be tailored towards, a supercharger combination, turbo combination, injectors, etc. And tuners will usually build up a database of these parameter files, and they'll merge them together to build the tune when you do get a custom coming in with variable parts and components, etc. But when you have a car come in with one of their kits that they're fitted, as you said, you can get OEM drivability out of it. It's going to work. It's going to make X power. It's the way to go, in my opinion. And you can take a kit from one company and the tune can be done from a totally different company. But as long as they've always done the tune for the same kit, it's the same sort of deal. And we see a lot of that in the US. And that's the most successful way to get a car that runs well, a customer that's satisfied. If you're mixing and matching parts, expect to pay a premium price. And if you don't, you might get a good result and some people might offer it. But I personally don't think you really can achieve that factory drivability. Some people might be okay not having that, but I personally wouldn't be. And that's sort of what got me started with the tuning myself.
Couldn't agree more. I know I've retuned so many cars, and this is more aftermarket standalone stuff, and the car won't idle. It bunny hops as you try and take off from stationary. It's literally just a pig, and the customer just thinks that is what owning a modified car is about. And it's absolutely not. I mean, within reason, you've got the right combination of parts, you should be able to achieve OE-like drivability. And, often I give these cars back after I'd spent a day with it or a couple of days with it, and the customers would come back to me after they've driven around the block, oh my God, I can't believe that it's the same car. And it's just having that understanding, the fundamental understanding of what you're trying to achieve and how the systems work, and then actually putting the time in to do the job. Unfortunately, the majority of tuners I see don't have a solid handle on that, which is one of the reasons the High Performance Academy exists, to try and sort of raise that level of knowledge and get better results out there for these enthusiasts. Just to come back, we've talked a little bit, or touched a little bit on data logging. You mentioned the number of parameters that are able to be logged, and obviously, as I've mentioned, data logging is so critical to reflashing. How's your data logging subsystem work there? I assume this is all integrated within the PCMTec product?
Yes. So we have a single package. A lot of companies will run a data logging and an editing package separately, or if you use WinOLS, you might use totally different packages for flashing, editing, and data logging. We have an all-in-one package, and that offers some real benefits there, because let's say you're data logging spark or knock retard, etc., and you go, okay, I want to see how much knock I'm getting in this area. I've got these RPM and load axes. You've got to copy and paste from one software package, etc. You just go pick the map. You hit map trace. It makes a histogram, which is what the industry calls it. It's technically not a histogram, but your axes line up. The numbers are the same. The cell size is the same. It's the one button click. You save a template, or you can just use your existing file to build out those histograms, and it saves a huge amount of time. The next major advantage is in our software, where possible, we list the X and Y inputs to every table, and they call it a DMR, so direct memory read, or PID or DID. There's lots of different terminology for it, but it lists the exact parameter to data log. So you go, okay, this table says load versus RPM. Now, there is not just one load value in the computer. There's literally like 100 plus of them. And some of them aren't actually load. They're inferred load, or they might be load with adders and things on them, or anticipated load and things like that. And so you might be logging load and it's not actually load, and you've just data logged something and applied a correction, and you've logged the wrong thing and you've corrected the wrong thing.
So your tables actually tell you the specific PID that needs to be logged for that table, or PIDs.
Exactly. Yep. So with 100% accuracy, you go, I'm logging the correct thing here.
Yeah, that's nice.
And like, this has caught some people out. And I think one example in the Falcon is they use inferred load, which is it's like an alpha N correction, which is an old-fashioned style of tuning, or when you have individual throttle bodies where you can't put a mass airflow sensor, or you can't put a pressure sensor on there because it's just too much noise, or it's just not physically possible. And they would come up with basically a model of RPM versus accelerator position and go, look, it's going to be roughly this load, which is probably plus or minus 30, 40%. And that would give you an inferred load. And that would be used on quite a few tables to make corrections. People didn't know this. And they were logging actual load when it should actually be inferred load. And in our software, that's immediately obvious. You can just click the DMR and log that, and you get the correct value being logged. And you can overlay that, apply the corrections within the same package onto the table. So yeah, map tracing is much simpler. However, if you're an aftermarket tuner, which does lots of different cars, different software packages, etc., a lot of people don't want to learn 20 different packages. Most of them will gravitate to Megalog Viewer and things like that. So we allow CSV export and import as well. So then you can just data log, you can export and use it in your favorite package, and you can use different filters and things like that, however you like to do it.
That is a tricky one. I mean, I use Megalog Viewer HD a fair bit, and there is a benefit. You're absolutely right. I mean, if you're dealing with 20 different packages, each with their own take on how data logging works, I mean, that can be super time consuming and confusing. And, you know, if you don't know the package inside and out, chances are you're not going to be getting the most out of it. So Megalog Viewer HD, learning that one package, yeah, that makes sense. It's a very powerful software package, but it sounds like from what you've just said there with the map tracing, etc., you'd be well advised to spend the time and learn how to use the PCMTec logging.
Absolutely, yeah. And a lot of people specialize in one platform now as well. As they're so complicated, a lot of people will tune like the Coyote 5-liter V8 engine only anyway. So they don't need to learn 20 packages. So it makes sense to learn one software package, or maybe two at the most. And that takes away that need. We've also got built-in filtering. We use just your standard like sample counts, things like that. So if you've got bad data in your data log, like heavy transients, like you've just stabbed the throttle randomly and got some data that at the sample rate didn't really line up quite right. We use a standard deviation filter as well. So you'll find that like on D-cell, you might have some values that are just so far out that they occur quite often because you get a lot of D-cell, but the value is drastically different to what it is in the area you're interested in. And that'll pull those values out, basically. It'll drop them off because they're so far out of the bell curve. And we've got, lots of... That's a simple approach to deleting bad data, opposed to building manual filters based on throttle position sensor and things like that.
Yeah, that sort of, it's so important to at least start with gathering good data when you're data logging as well, but when you can filter out some of the garbage that inevitably is going to creep in no matter how careful you are, good quality data is going to make for a much better and faster tune. At this point, we've really been talking exclusively about the engine control side of things, but of course, in these late model vehicles, we've got a TCM or transmission control module as well. Are you providing any support for transmission control tuning at this point?
Yes. So not all of them run a separate TCM. It's kind of interesting which ones do and don't. In the Falcon mode, they do run a separate, so that's the Australian Barra. They do run a separate module, so we've mapped that out and have full flash read-write data logging support for that. In the US domestic market, most of the vehicles run the transmission control from the powertrain module. So it's very easy. It's basically, we can treat all tables as, I don't care if it's a transmission or an engine table, we map them out the same. You can read and write, flash, data log those without issue. The number of parameters in a 10R80, which is the 10-speed gearbox in the modern Ford, is staggering, but we've sort of narrowed down the common areas that people are interested in, like shift pressures and shift times, how much torque reduction you need, etc. And that brings me to another interesting point with torque reduction. The engine needs to know how much torque it's making to know how much torque to reduce, and that's where coming up with a spot-on calibration is very important instead of fudging your way through it, because if you're making 800 newton meters of torque, but the engine thinks you're making 600, it's going to make the wrong torque reduction. You end up with either banging gears or slipping gears, etc.
Yeah, I mean, even that 600 versus 800 newton meters being sent through to the transmission control side of things, I mean, that's going to affect line pressures, etc. as well, and could result in slipping clutches. And I've seen this in the GM world as well. We had a supercharged LS3 at one point, and I think, I'm really stretching my memory here, I think essentially the calibration for the injectors or characterization for the injectors was incorrect. So the calibration had then been fudged to get the air-fuel ratio correct, but essentially the whole model inside of the ECU was then calculating the incorrect torque, and that ended very badly for several transmissions before the problem was found.
And people sometimes then go and just add pressure to compensate for it, which will work. And if you look at it from the outside, it's doing what it's supposed to do, but probably only in that one area. Whereas if it had calculated the torque model correctly, then the torque reduction would be correct and you wouldn't have to fudge those pressures. Obviously, you're going to be adding pressure when you're making more power, but to ensure the clutch doesn't slip. But even then, you still need the torque model to be accurate because it's such a wide variety of scenarios, like RPM and load, etc.
Yeah, and I think that the moral of that story there is it's really important with these modern controllers to understand how it works, understand that torque model, and then make sure that you're not actually fudging numbers to kind of get the result. It really needs to be done properly. And classic example of that is the injector characterization I just mentioned. It's going to be difficult, if not impossible, just to jam a random set of eBay injectors into a modern Mustang and stumble upon the correct characterization numbers for those injectors. I mean, you might be able to get the thing to run half okay, but it's not going to be right. So it's one of those areas where you really need to buy injectors with drop-in numbers for the controller, so that you can characterize them properly, and then everything's going to work seamlessly, or that torque model's still going to be absolutely spot on.
Couldn't agree more there. With good quality parts from known reputable dealers and ones that provide data, which is not many, but the ones that do.
I mean, I think injector dynamics really sort of changed the whole aftermarket injector scene there. I mean, these days they're not the only ones, but at least as I said, they were the first ones to actually dive deep into the operation of an injector and characterize how these seemingly simple products work. They're not that simple when you dive into it, and then provide us in the aftermarket some actual solid data that made our lives easier and in turn gave a better quality calibration. And I think we'll move towards wrapping this thing up. Been a really interesting chat, and I've definitely learned a lot. We've got the same 3 questions we ask all of our guests, and the first of those is, what's next in the future for you and PCMTec? Where are you going with this product? Are you looking to incorporate different makes, or is it going to be narrowly focused on Ford?
So whilst it's narrowly focused on Ford, the Ford range is ginormous, and also a lot of other companies are dropping their V8s and high performance engines. So Dodge, GM, a lot of those companies they're going to make like their high end, like Corvette, basically race car sort of car, like street legal, but very high end, and SUVs and pickup trucks. Whereas Ford have committed to keeping the Mustang alive at least for another 8 years, I believe. So I think it's a smart business decision from our part to really stick with the Ford platform and really bridge that gap between the aftermarket and OEM functionality, to add as much as we can to it to really differentiate ourselves from other players in the market, and basically just keep building out that support for the Ford platform.
I guess when you say the scale of things, 900,000 F-150s, I think you mentioned that's a pretty big market, and that's just one model. So I think while it sounds like you might be limiting yourself, sticking just to Ford, I mean, there's obviously a massive market there regardless.
Yeah, we don't want to spread ourselves too thin. We don't want to jack of all, master of none. That's not our goal. So yeah, we want to pick a solid direction and really focus on that and do it very well and really stand out in that area.
Well, I think if you spread yourself too thin, it almost comes back full circle to finding those same problems that you saw with SCT and HP tuners back when you got your start, and that they had tried to cover all of these models and really weren't doing a good job of at least the Australian domestic market forward. So that sort of comes back to the same situation you'd likely get yourself into.
You definitely open yourself up to competitors. Yes, someone will come in and cut your lunch, that's for sure.
All right, our next question. Is there any advice you'd give to a younger version of yourself, or maybe one of our enthusiast listeners, to help reach where you've got to today in your career faster, or potentially avoid some of the pitfalls you've seen along the way?
Honestly, I think the approach that I took, whilst it wasn't a planned approach, worked very well in working in sort of the corporate world and seeing how things do work in the business side of things, and also seeing risk mitigation procedures, working with staff and things like that, and then getting a handle on some really complicated systems. You don't get that if you start your own business from day one. If you go work for a large company, you can really see some cool stuff and get some great experience early on in your career and then build on that later. But you have to enjoy it. If you don't enjoy it or find something about it you like I find programming enjoyable. It's almost like people say it's like a art form almost. It's like painting. You can build a certain piece of software 50 different ways. So it's very enjoyable to build it and perfect it, even if it doesn't need to be perfected. But there's lots of different things like that you can do in programming. So that was my passion. And basically anything software-wise, whether it was mating it with the automotive area or somewhere else, was still enjoyable. So yeah, if you find enjoyment in something, do it. But also often it's a bit of a catch-22. You don't enjoy things until you're good at them. So you need to practice at something and get good at it. And then you'll find you probably enjoy it because you're good at it. So just keep doing what you're doing and don't give up. Just keep practicing and you'll find something that way.
Yeah, I think there's a couple of things that I'll add in here. I mean, the old story, if you love what you're doing, you'll never work a day in your life. And I mean, that couldn't be more true. In my situation, I've been very fortunate to make what was and is still my passion into a career. Obviously, not everyone has is the benefit of being able to do that. But if you can, and you can make money doing it, then absolutely. The other thing you mentioned there about sticking with it until you're good at it. I mean, I think these days there's sort of an expectation that you'll be proficient straight out the gate. And the old story of the 10,000 hour rule, 10,000 hours to become expert in any field. I think that probably still holds true for the most part. So
absolutely, you can build some very cool stuff very quickly, but a lot of it's smoke and mirrors. It's when you dig deep into it, you'll see it's not actually that advanced or clever. And someone who really does have that amount of experience, it does show. And you really do need to spend those hours to get proficient at something.
The other thing that comes into this is the Dunning-Kruger effect, which I've seen through my career. You start something that you're brand new at, and you put a little bit of effort into it, and all of a sudden you think you're a master of it, and no one else knows what they're doing. And literally, this in the tuning industry, the longer I've been involved, the more I start questioning my own assumptions, and the more I realize I don't know what I don't know. So it's a very interesting learning curve when you start getting into something.
Programming and reverse engineering is like that as well. The more you learn, the more you realize, wow, I don't know as much as I thought I did. And then you get better at it over time, and then you can recognize where your pitfalls are. Same with business as well. You learn very quickly what you're good at and what you're not, opposed to day one when you think, this is easy, I can do all of this. And
I mean, on the flip side of that, I'd say that if you could master something in a week, it's probably really not going to hold your attention very long. So that's why I'm still passionate about the automotive industry, engine tuning and aftermarket electronics. There's always some new technology, there's always something new to learn. It just never stops, and that keeps me passionate.
Also, if you can master it in a week, then there's probably 10,000 other people who have done it as well.
Yeah, there's not a large barrier for entry there.
Yeah, you want to sort of carve out a niche for yourself that requires time, and that means you're going to have less competition.
100%. All right, our last question for today. If people want to follow you and see what you're up to, see your product and maybe purchase your product, how they're best to do so? What are your social media accounts, websites, etc.?
So everything's online. We're a totally online store. So it's www.PCMTec.com. There'll be a link below. And we have several products. So the Australian market, we sell 3 products. Our basic for the DIY, the professional and the workshop edition. And that starts at $300 Australian and works its way up. For the US market, we have a sort of a DIY entry-level product that starts at $130 USD for our Pro Tuner product, and that covers the US market. We have a special on at the moment for users who are using SCT with the X4 and anyone else in that market for approximately $990 USD. And that gives you access to the full custom operating system, all of the parameters, everything, and the ability to export to an X4 or any of the other flash formats we support. And if anyone's really interested, there is a blog we started back in 2016 on the PCM hacking forums. So I'll send the link through for that later. And that's got some really geeky stuff in there for those who are interested in reading assembler code.
For those who want to go deep. All right, well, really interesting there. As usual, we'll put all those links into the show notes. Look, Roland, it's been great getting some background on yourself and the PCMTec product. So thank you very much for your time.
Great. Thanks a lot.
If you enjoyed this episode of Tuned In with Roland from PCMTec, we'd love it if you could drop a review on your chosen podcasting platform. These reviews really help us to grow our audience, and that in turn helps us to continue to get more high-quality guests. To say thanks, each week we'll be picking a random reviewer and sending them out an HPA t-shirt free of charge anywhere in the world. This is also a great place to ask any questions you might have too, and I'll do my best to answer them if your review gets picked. So this week, a big shout out to Quarry Wood from Canada, who has said, absolute must listen for gearheads. Unless you've been living under a rock, you're probably already familiar with this podcast, but if not, stop searching and dive in right now. The plethora of topics, depth of detail and breadth of knowledge far surpasses the competition, if you can even call them that. Thanks for your kind words there. And we've actually got a question as well on this review. For a sucker with an ECU in his daily that has to be bench flashed with no OBD2 support and no readily available tune or support via HP tuners, etc., is my only option learning to use WinOLS. Well, unfortunately, if there is no commercial solution, that probably is the way. Usually, if you've got a car that's at least somewhat popular in the performance aftermarket, there would be commercial reflash solutions, either commercial or open source. It sounds like, in your case, that isn't in existence. So yes, WinOLS would be the option, or alternatively, you could always sell it and buy something with a bit more support. If you do want to learn how to use WinOLS, we do have our WinOLS Mastery course as well. And to say thanks for your review there, if you get in touch with your t-shirt size and shipping details, we'll get a fresh tee shipped straight out to you. All right, that concludes our interview. And before we sign off, I just wanted to mention, for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.